So now I will explain how to solve the second order differential equation by using Laplace transform. These two initial conditions are given as it is a second order differential equation. So here we are going to use again the Laplace transform of derivatives. So if we denote the Laplace transform of y by capital Y of s, then the Laplace transform of y dash, that is first derivative of y, is given by sy of s minus y of 0, and second derivative for y is given by this formula. And here, as it involves second derivative and first derivative, we have to use both the rules. So let's start solving. Again, the first step remains same, applying the Laplace transform on both sides. What we get? Laplace transform of y double dash minus Laplace transform of 5y dash plus Laplace transform of 6y equal Laplace of e power t by linearity property. Then we name the term as 1, 2, 3 and 4. The procedure is same, just the number of terms increased here. Laplace of y double dash. So by using this formula, this is s square y of s minus s y of 0 minus y dash of 0. Now we can see this y of 0, y dash of 0. The values are available here in the question. Substitute it. This gives you s square y of s minus s times y of 0, the value is 0, minus y dash of 0, the value is given as 0. So s multiply 0, this term cancels, becomes 0. So we left with s square y of s minus 2. Okay, this is the value of Laplace of y double dash, the first value. Now similarly we calculate the second term, which is Laplace of 5y dash. Now 5 is a scalar, take it outside, Laplace of y dash. Laplace of y dash using this formula. So that's the reason this formula should be correct, because if you do mistake here, everything goes wrong. Sy of s minus y of 0. Again y of 0 from here, the value is 0. So this gives you 5 sy of s minus 0. So this is 5 times s capital Y of s. See, here it is important how you write 5 and s. Don't get confused between 5 and s. Okay, you should write in such a way that you are able to distinguish between them. Third term, Laplace of 6y. Again 6 being a scalar, take it outside, Laplace of y. Laplace of y is nothing but y of s. So this gives you 6y of s. And for fourth one, using the rules of Laplace transform, e power t. This is 1 over s minus 1. Now after getting the values of 1, 2, 3 and 4, substitute it here in this equation. What we will get? S square ys minus 2. In between the sign is negative. Second term value is 5s y of s. Next term is positive plus 6 y of s equal to 1 over s minus 1. Now again what we have to do? We have to keep the terms with ys. These are the three terms with ys. We keep them here on the same side, and the term without ys, which is 2, we move it to the other side. So this is how it becomes a square ys minus 5sys plus 6y of s equal 1 over s minus 1. This is minus 2. When it goes to the other side, it becomes plus 2. Okay, then here ys is common. Take it as a common factor. So what you left here from here? S square. And then here minus 5s plus 6 equal to, on this side when you simplify it, again working on the same idea, you are adding a rational number and an integer, so it's like say 2 over 1. So when you write in the denominator s minus 1 times 1, which is s minus 1, and then 1 plus 2 times s minus 1. So this is how we can work with. Okay, then when you simplify it, you will get this side as, see, 2 multiply s, 2 multiply 1. So it is 1 plus 2s minus 2 over s minus 1. This is the value of s square minus 5s plus 6 times y of s. Let's solve it. So here plus 1 minus 2. We can add them together. So what it will give you? S square minus 5s plus 6 y of s equal, from the previous screen, 2s minus 1. 2s minus 1 over s minus 1. Right? Now, what will be the value of y of s? To get y of s, we divide both sides by this term. So it gives you 2s minus 1 over s minus 1, s square minus 5s plus 6. So again, ys is nothing but Laplace transform of y. Now we are solving this differential equation, means we have to find the value of y. So doing the same thing as we have done earlier, Laplace of y is 2s minus 1 over s minus 1, s square minus 5s plus 6. This gives you the value of y as the Laplace inverse of 2s minus 1 divide s minus 1, s square minus 5s plus 6. And now you know how to find the inverse Laplace transform. So to find the inverse Laplace transform of this term, we need to again use of partial fraction. So we write 2s minus 1. Now we can see here the term s square minus 5s plus 6. So as we have this term s square minus 5s plus 6, so the method of partial fraction says that it's always better to split it into two terms if possible. So it is s minus 2, s minus 3. So we write this thing in place of this s minus 2, s minus 3, and here s minus 1. Now we have three linear factors. So the rule of partial fraction, a over s minus 1, b over s minus 2 plus c over s minus 3. One constant corresponding to each linear term, each linear factor. Now again we have to simplify. So we simplify like s minus 1, s minus 2, s minus 3. This will be the denominator. We look for the terms with a, with b and with c. Okay, this is what we are writing for 2s minus 1 over s minus 1, s minus 2, s minus 3. These terms, what we will do, we multiply all of them, all these terms by the denominator. Denominator is s minus 1, s minus 2, s minus 3, just to get the coefficients of a, b and c. So below a we have s minus 1. So s minus 1 cancels, we left with s minus 2, s minus 3. That will come with a. With b, below b we have s minus 2. So we left with s minus 1 and s minus 3. And for c, we already have s minus 3. So we left with s minus 1 and s minus 2. Okay, then we compare the numerators. So it will give you 2s minus 1 equal to a times s minus 2 s minus 3, b times s minus 1 s minus 3, and c times s minus 1 s minus 2. So let's write it over here. 2s minus 1 equal a times, with a we have 2 and 3, s minus 2 s minus 3, b times, with b we have 1 and 3, s minus 1 s minus 3, and with c we have s minus 1 s minus 2. Now as we have three constants a, b and c, we have to substitute three different values of s. Those values we get from here. S is equal to 1, 2 and 3. So let's work on it. So if I put s minus 1 equal to 0, this gives me s is equal to 1. Substitute it here. S everywhere here. So here at this point you can do it directly, means you don't need to write all the expression. What I mean is, you know that s minus 1 is 0. So it is coming in the term of b and c. So it means when we replace s by 1, only a is non-zero, but b will become 0 and c will become 0. So it's okay if you don't write these two terms. So this gives you 2 minus 1 as 1, which is equal to a times minus 1 minus 2. B and C cancels out. So minus 1 times minus 2 gives you 2a. This is equal to 1. So this gives a as half, 1 over 2. Second value, s minus 2 equals 0, gives you s equal 2. So when you substitute it here, s minus 2 factor is available with a and c. So these terms become 0. So you get 2 times 2 minus 1 equal, a becomes 0, you have non-zero only for b, which is 2 minus 1, 2 minus 3, and c also becomes 0. Okay, so 2 times 2 is 4 minus 1 equal, b times 1 times minus 1. So this gives you 3 equal minus b, giving you b is equal to minus 3. And the third value, s minus 3 equal to 0, which gives s is equal to 3. So when you substitute it here, s is 3. So again, this a term will cancel out, b term will cancel out. You will left with only non-zero c. 2 times 3 minus 1. So a will become 0, b will become 0, and you have with c 3 minus 1, 3 minus 2. You can do it in regular way by writing the values for a and b. You will end up with the same thing. No need to worry about it. 6 minus 1. And with c we have 2 times 1. 6 minus 1 is 5. 2c. This gives you c equal 5 over 2. Now, after getting values of a, b and c, we substitute it here at the very first place where we introduced a, b and c. Remember, this multiplication term is not there. This is just for our calculation to get the coefficient of a, b and c. Okay, so better I will erase it to avoid any confusion. I cannot. Okay. So we get 2s minus 1 over s minus 1, s minus 2, s minus 3 as a, that is half over s minus 1, plus b, which is minus 3 over s minus 2, plus c over s minus 3. Now this 2s minus 1 over this term is required for y. So y is Laplace inverse of this term. So we get y as Laplace inverse of 2s minus 1 over s minus 1, s minus 2, s minus 3, which is same as finding the inverse Laplace transform of this term. So half is a constant, take it outside, Laplace inverse of 1 over s minus 1. Then plus minus gives you minus, again 3 is a constant, take it outside, Laplace inverse of 1 over s minus 2, plus 5 over 2 is a constant, Laplace inverse of 1 over s minus 3. Now, by using the rules, we know that for 1 over s minus 1 it is e power t, s minus 2 e power 2t. For this it is e power 3t. So this gives you the final answer as y equal half e power t minus 3 times e power 2t plus 5 over 2 e power 3t. This completes the solution of this differential equation. So in this way, as we have solved it for this one by using this rule, sometimes it is possible that you have one linear, one quadratic, one linear and one quadratic factor or a linear factor repeated twice. So all the possible cases are possible in this question as well. So the idea is begin with applying the Laplace transform, then separate the term of y of s, get the value of y of s,